Good morning, everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this particular video lecture series, I'm going to explain about mutual information and the channel capacity in the information theory and error controlling. Mutual information is nothing but will consider a discrete memoryless channel first. So where in that channel we have to give the input and also the output. So in this discrete memoryless channel, it uses a statistical model that is with an input of x and an output of y, which is where the output is nothing but a noisy version of the input. So both x and y are there will be considered here as a random variables. So the channel is said to be discrete when both of the alphabets x and y should have finite sizes. A channel is said to be memoryless when the current output depends on the current input, not on the previous ones. So the information can transfer from a transmitter through a channel to a receiver. So prior to the reception of a message, the state of knowledge at the receiver about a transmitted symbol x of j is the probability that x of j would be selected for transmission. This is a prior probability P of xj. After the reception and the selection of the symbol y of k, the state of knowledge concerning x of j is the continuous probability P of xj by yk. So the Venn diagram representation of this mutual information is shown below, where h of x by y and h of y by x is shaded fully there. So in between both parts will be called it as a I of xy, that will be called it as a mutual information. So h of x entropy of a channel input, this side h of y entropy of the channel output. So according to conditional entropy, let us consider a channel whose output is y and input is x. So the entropy for the prior uncertainty will be x, which is equal to h of x. To know about the uncertainty of the output after the input is applied, let us consider conditional entropy given that y, which is equal to yk. So h of x by yk, which is equal to summation of p of xj by yk log of 1 by p of xj by yk. The mean value of h of x by yk, which is equal where the output alphabet y is h of x by y, which is equal to h of x y, which is equal to yk into p of y of k. So the final derivation is p of xj comma yk log of 1 by p of xj by yk. So now considering both the uncertainty conditions before and after applying the inputs, we came to know that the difference, that is h of x minus h of x by y, must represent the uncertainty about the channel input that is resolved by observing the channel output. This is called as a mutual information of the channel. Denoting the mutual information as I of x, y, we can write the whole thing in an equation as follows. I of xy, which is equal to h of x minus h of x by y. Hence, this is an equational representation of a mutual information. The information gained about the channel input x of j by the reception of channel output y of k is the net reduction in its uncertainty and is known as mutual information I of xj by k. So where I of x comma y, which is equal to initial uncertainty minus final uncertainty. Initial will be represented as h of x, final will be represented as h of x by y. So there are various properties of a mutual information. So the various properties of a line coding are: mutual information of a channel is symmetric, then the mutual information is non-negative. Mutual information can be expressed in terms of entropy of the channel output, where h of y by x is a conditional entropy. Mutual information of a channel is related to the joint entropy of the channel input and the channel output, where the joint entropy h of xy is defined as p of x jyk log 2 of 1 by p of xi minus yk. So this is nothing but a mutual information. The discrete memoryless source, a source from which the data is being emitted as a successive intervals which is independent of previous values, can be termed as a discrete memoryless source. This source is discrete as it is not considered for a continuous time interval but a discrete time interval. This source is memoryless as it is fresh at each instant of time without considering the previous values. Channel capacity, the maximum average mutual information in an instant of a signaling interval when when it is transmitted by the discrete memoryless channel. The probabilities of the rate of maximum reliable transmission of data can be understood as the channel capacity. It is denoted by C and it is represented in bits per channel use. Channel capacity constraints. The calculations of C involves maximization of mutual information over the J variables. It must satisfy two constraints. The one is P of xj, which is less than or equal to 0 for all j, then P of xj, which is equal to 1. Channel efficiency. The transmission efficiency or channel efficiency is defined as eta, which is equal to mutual information by maximum mutual information. Then the redundancy is here. Noise-free channel is represented as I of x is to y, which is equal to h of x. And it is finally represented by C, which is equal to log 2n with a symbol. Assessment. This is the assessment. Thank you.